Example problem 7 asks us to calculate the de Broglie wavelength of an electron traveling at 275 kilometers per hour. So we know that the velocity in this problem is going to be 275 kilometers per hour, and that we need to be in units of meters per second. So we're going to do a compound conversion, go from kilometers to meters. And then we're going to handle our hours to seconds. So giving the one to the thing with the prefix and the metric system constant to the base unit here. Kilometers cancels and you're left in units of meters. And then the conversion, as you can see in the problem, from hours to seconds is that 1 hour equals 3,600 seconds. So hours cancels and we're left in seconds. So in your calculator, if you multiply 275 times 1 times 10 to the third divided by 3,600, you will get a velocity of 76.38 meters per second. So now we're going to have to go back and use that particle momentum equation, and that's going to be P equals me times v, where me is the mass of an electron and v is the velocity that we calculated. So the mass of an electron will always be 9.11 times 10 to the minus 31 kilograms times 76.38 meters per second. Now would be a good time to put your calculator in scientific mode, since to the minus 31 is a very small number with a lot of zeros. And so when you multiply the mass of an electron times the velocity that we calculated, you get a particle momentum of 6.958 times 10 to the minus 29 kilograms meters per second. So kilograms meters per second. Now that we have a P, we can go ahead and use the de Broglie equation to calculate the wavelengths. So wavelength equals h divided by P. H is going to be Planck's constant, and it will always be 6.626 times 10 to the minus 34 joule seconds, divided by the P that we calculated, so 6.958 times 10 to the minus 29 kilogram meters per second. And when you divide Planck's constant by the P that we calculated, you'll get 9.522 times 10 to the minus 6 meters as your final wavelength. Let me know if you have any questions about how to work example problem 7.